I will introduce a technique for finding the derivative. As you can see, the equation d over dxc equals 0. So what that means is if c is a constant, then the equation will equal 0. This is the easiest concept of this topic. Now we can move to the second one. If a is any real number, then whenever you have variable to a power, just pull the number out front. According to the rule, the power of a should also minus 1. So the third one is a combination of the first rule and the second rule. If there is a constant in the equation, so pull the constant out front as well. The last two equation is showing you how to find the derivative when there is more than one factor in the equation. It follows the technique that I introduced in the previous slide. The first step you need to do is find the derivative for each factor, then plus each factor or minus each of them. We have used the generalized power rule to find the derivatives of a composite function of the form f of g of x, where f of u equal u power of n is a power function. But what if f is not a power function? It is a more general rule, the chain rule, that enables us to compute the derivatives of many composite functions of the form f of g of x. An example, firstly, we can let u is equal to 2x plus 1. Therefore, y can be transferred to y is equal to u power of 7. Then calculate du over dx is equal to 2. Then dy over du is equal to 7 times 2x plus 1 power of 6. Finally, we can find y dash is dy over du times du over dx, which equals 7 times 2x plus 1 power of 6 times 2, equal 14 times 2x plus 1 power of 6.
Let's see the product rule. If a function can be represented as y is equal to fx times gx, then we can get its derivative y dash is equal to f dash x times gx plus fx times g dash x. To well understand what we've talked about on last page, let's see an example. Calculate the derivative of y is equal to 2x times square root of 5x plus 3. The first step, transfer y equal to 2x times 5x plus 3 power of half. Second step, we can see that y is a composition function which includes 2x, 5x plus 3, and the square root of 5x plus 3. So let fs equal to 2x, we can get f dash x equal to 2. And then let hx equal to 5x plus 3, we can get dh over dx is equal to 5. And then dj over dh equal to half times 5x plus 3 power of minus half. So we can calculate dj over dh times dh over dx equal to dj over dx equal to 5 over 2 times 5x plus 3 power of minus half. The last step, by the product rule, we can get y dash equals to 5 dash x times gx plus fx times g dash x equal to 2 times 5x plus 3 power of half plus 2x times 5 over 2 times 5x plus 3 power of minus half equal to 2 times 5x plus 3 power of half plus 5x times 5x plus 3 power of minus half, and finally we can get 2 times 5x plus 3 power of half plus 5x over 5x plus 3 power of half. Another useful rule to calculate the derivative is quotient rule. If a function can be written as y is equal to fx divided by gx, then we can get its derivative y dash is equal to f dash x times gx minus fx times g dash x divided by the square of gx. Assume that gx is not equal to 0. Let's see an example. Calculate the derivative of y is equal to x cubed over x minus 1. The first step, let fx is equal to x cubed. Then we can get f dash x equal to 3 times x squared. Let gx equal to x minus 1. We can get g dash x is equal to 1. So the y can be written as fx over gx. By the quotient rule, we can get y dash is equal to f dash x times gx minus fx times g dash x divided by the square of gx. So the equation can be written as 3 times x squared times x minus 1 minus x cubed times 1 divided by the square of x minus 1. So 3 times x cubed minus 3 times x squared minus x cubed divided by the square of x minus 1 is equal to 2x cubed minus 3x squared divided by the square of x minus 1.